Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is number of enclaves. So let's go to LeetCode and go through this problem. You are given an M cross N binary matrix called grid where 0 represents a C cell and 1 represents a land cell. A move consists of walking from land cell to another adjacent land cell, 4 directionally connected by the way, or walking off the boundary of the grid. Now return the number of land cells in grid for which we cannot walk off the boundary of the grid in any number of moves. Alright, so basically let's see. So we have simply been asked to count the number of enclaves. What are enclaves? It's by definition, it's like some territory that is like distinct from like its surrounding territories or like regions, countries or whatsoever. But here like we have been given it in the water, and now we need to count first of all the number of enclaves. So here if you see right here in this particular grid, we are given these piece of lands represented by water, and this represented by 1. This is a land, and these are all basically these, this, and this. These are water. Now we have to count the number of enclaves. So by the way, this one, although it is connected with other ones, but this in itself is one enclave. This is one enclave, and this is one enclave, and this whole thing has all of these 3 pieces of lands as enclaves, and the only reason is these are not in touch with the border. So this one right here is not an enclave, because if you go basically to the left, you can walk off the grid, and walking off the grid is basically you are getting in touch with the society or territory. So you're part of like some bigger thing. You're not some distinct ethnic group yourself. Now how do we count it? I'm sure like we have already, like you already solved the problem number of closed islands, number of islands. This problem is going to be exact same, just with one minor difference, is that this time we are not just asking this number of this piece of islands. So we're not just asking that, okay, because this right here is a closed island, something like that, then you just return 1. We're not returning 1, we are returning 3. We are returning 3 because this whole island, this whole group actually contains 3 pieces of land which are enclaves in itself. All right, so we will be returning 3. So what we are going to actually do is traverse our grid, and then once you see a 1, then on that 1 we are going to basically run DFS. So we'll have like a DFS right here. Let me just write the pseudocode for our DFS. Alright, so what this DFS will do, this will take row and column, and by the way, using our for loop for R in basically number of rows, for C in all the columns, if by the way this R and C not in visited already, so we'll have a visited set, visit already, and this grid that's given to us, I am seeing basically a 1 at this particular cell address. So if this is the case, then I'll call DFS and I'll add that to my answer. All right, I'll add that, whatever this will return, add that to my answer. So answer plus equals DFS and row and column. And by the way, I will actually return 2 values from this DFS, because first thing is the number of enclaves, and second thing, if that is actually a proper valid enclave, like is it not is it not like surrounded by water, or maybe like just only thing it makes this group of ones not enclave is like if it is touching the border. Okay, so we'll return that. So here I will be returning this value, and I will have a check here. Well, that's not the most important thing. The most important thing is this our DFS function. and let's write that. Okay, so here this will be calling our DFS. Now DFS will be returning two things. First thing is like we're going to have our visited set. So let's have it somewhere, visit set. Now this RNC right here, what I'm going to do is first I'm gonna mark a variable that, well, this one right here that we just like, okay, this 0 we don't have to run DFS, there is no point, but this one is a potential enclave. Now we will return if this is an enclave and how many piece of land does it have. So that will be, those piece of land will be different enclaves in itself, and that's what we will be adding it to our final answer. So here initially I'll say is enclave, or let me just have it like short, en is en. Initially it will be true. Now because I'm calling this DFS on R and C, row and column, which was equal to 1, so initially I'll just say this num enclave, num en will be 1, num en will be 1, and then I can actually get into, I will add it to my visit set, by the way. So visit dot add this R and C as a group, by the way, this tuple, and then if this R and C, so by the way, this on the border, in the code we will have proper proper conditions to check this, but here just like I'm just saying it, if this is on border, then is en will be false. Now let's get into all the directions. So of this one, so I will actually be, because this is border, so it will become this, and it's not an enclave, it will become false for this particular one. But like later let's say if you started exploring this one, here you want to explore its neighbors to check if this is part of the border, or if not, then how many ones it is connected to, and if those ones are also not part of the border. Clear, very clear. So for this, let's say dr and dc in, we can have all those directions, so 1 0 0 1 -1 0 and 0 -1. So by the way, all those 4 directions. Now here we are going to have a check if these by the way, this new dr, new r and new c that we should be getting by adding dr plus r and dc plus c. All right, I hope you can see that. So now we have this new r and new c, this new address that, let's say if you were exploring, this one right here, let me just clean it up. So let's say if you were exploring this one right here, so now you will actually want to explore all its neighbors, right? All its neighbors. By the way, this is already not an enclave, so it doesn't matter, but still, we will have to explore its neighbors to mark them visited. So now it will try to, let's say, explore this right here. So I want to check like few things. What are those things? Like say I'm not going out of bounds. So if I'm not going out of bound and I'm still seeing a 1 on the side on one of the neighbors, so this is how I will write. So if this new r is actually greater than equals to 0, and this new r is actually less than my big R, and then new c, same thing, new c is actually greater than equals to 0, and these are and, by the way. So and this new c is actually less than my big C, and more conditions. What is that? So the grid at this, remember this new R and new C, I'm just gonna call it NR and NC, is equals to 1, by the way. So if this is equals to 1 and it's not in visit set, and this new R and new C not in visit set, you can't see it anymore, so I'll just bring down the size a little. Now you can. All right, so not in visit, then what we're gonna do, we are going to do is we're gonna call a DFS on it, which will return us. So we will call DFS on new R and new C, and at the end, by the way, this should return, this function should return, this DFS, two things, return two things. What are those two things? First is Enclaves, and the second thing is, or maybe second thing enclave and first thing this num enclave. So num enclave, num en, and then second thing would be is en. All right, is en. So these are the two things I'm returning, but like let's collect these two things into basically. So this will be returning two things to me. So first is count and second is enclave. And if and by the way, we will just like whatever my DFS returns to me, I will just like increment the count. So num en would be basically plus equals would be this C is the count, this is E, by the way. So enclave and C. I know, please forgive my handwriting here. So C and then E would be, and num this right here is en would be and equals to this E. And by the way, in the end we will be returning this thing, and here by the way, here if this first thing is on the first index, if this is true, only then we will add it to my answer, and finally I will return my answer. If you are an awesome coder, you must have understood everything I said. Because I know things got messy a little bit, but just remember, this is how the code is going to be. I just like to write pseudocode while like going over the problem, is like it just like really help things to get like things clear in your head, that there's no point in like just blabbing about do this, do that, and like finally you have an answer. But like let's also translate that to your actual instructions, because at the end of the day that will be giving us solving the problem at the end of the day, and it's very important that those steps are written like very in a particular order. So you can go over this again. So we will let's say we will be at one point we notice this one right here, initially it's going to have initially it's going to say here like is enclave, yes, let's mark it true. Num enclave initially 1, because you were called, your DFS was called on one of the grid 1's piece of land that you saw, but then you are going to check like if it is on the border. Yes, this particular thing was on border, so you make this false, and so this will not be ever added into your answer. However, you will still go through all these steps just to mark, let's say in another case, like there was another 1 present right here. Let's say this was a 1 right here, this was a 1 right here, which means there's this, if this was the 1 right here and this was the 1 right here, we would still, by the way, these are on border. So let me just like take another example. Let's say if this was a 1 right here, if this was the one, then I still want this to be actually explored by my DFS such that it can mark this is still as part of is enclave false, but mark them visited. So the next time I'm not like actually visiting it, because if this is in touch with this one, this is also in touch with this one, which is part of the border. So this is the border, then this I don't want to consider this as enclave, and next time this will also make this not an enclave, this not an enclave. So there will be no enclave in my answer if this was a one. So that is why, although I'm marking it in enclave false, but still I'm running that. So by the way, after you run through this will get cancelled, but you will mark all these visited, right? All of these visited. So this, not that one. So these are already visited, then this one visited, this one visited. Now you're gonna explore this one. Once you start exploring, is enclose true, number of enclaves 1, then you actually see that this is not part of the border. Then you start the exploring its neighbors. So you go to this neighbor, it's a 0, this is a 0, this is a 0, and then you actually check this one, this is a 1, not part of the borders, or not part of, like, you know, it's not out of bounds. So what you'll do is actually just increment this right here, num enclose, it will return 1. So just one more thing, because this number of enclave is 1, so even if nothing is counted here, it will still return 1 from here, which can be later added right here when your DFS returns to your neighboring cell. All right, too much talking. Let's write the code. All right, let's write the code. Yeah, by now if things should be clear. All right, so let's get our dimensions. So row, column, and let's make a visited set. So length of the grid, then we're going to get length of the grid's first row, which will give us the length of the column, and then we will create a set, visit set. Finally, let's go through our the grid. So for r in range r, and then for c in range capital C, and if by the way, this has to be equals to 1. So grid at R and C, this is a land, and this is not in visit set. So this pair of cell, the cell is not in visited. If this is not in visited, then I will call DFS. So DFS on R, C. This will return me two things. What are those two things? Those two things would be is en enclave. I can write it like that, and then was that the enclave? Yeah, CLAVE. Yeah, and num enclave, num enclave. All right, so num enclaves, and if num enclaves, sorry, is enclave, if this is an enclave, this will return me some certain number of enclaves that I can add it to my answer. So I'll just say answer equals to 0 in the beginning. And why it's not like formatted properly, and now I can say that my answer, I can add that to my answer, because that is actually enclave. It was those, that is the group of ones I just found out through DFS, which I have not yet written, and I'll add it to my answer, and then I will return my answer. Awesome. How easy and nicely that is written, right? Beautiful code. All right, and maybe it would be better if I write the DFS right here and answer like close to. All right, so let's write our DFS function that will be taking row and column. Initially, I'm gonna say I'll say that is en enclave, enccv, this is what I'm gonna say, enclave is gonna be true, and num enclave, and I think this is actually better, right? Num enclave is going to be 1, then I will add it to my visited sets. What am I adding? I am adding this row and column, and I'm only like, it's so nice, like once you have written the pseudocode, you already have like everything you're writing so clear in your head. So now let's check if r is equals to 0 or c is equals to 0, not TypeScript or JavaScript, or so basically the border cells. So if row is equals to actually r minus 1, or c is equals to c, capital C minus 1. So if it is the border cell, then darling, you are not enclave. So we will make is enclave already false right here. So we will say, oh, you're false. Now let's explore all the neighbors of this cell. So for dc, not c, dr, row first, we can see, we can do the column first, but doesn't matter. But this is the convention. In the pairs of 1, 0, -1, 0, we are decrementing the row, then 0, 1 and 0, -1. 0, -1. All right, we got all the directions. Let's create the new row and new columns. So that will be dr plus r, dc plus c. We got a new row and new column. So if this new r is actually inbound, so new r is greater than equals to 0, and new c is greater than equals to 0, and new r is actually less than my r, and new c is actually less than my c. Come on, yeah, I'm just talking too much, but like only because things need to make sense. So if these are within borders, and one more thing is that if it's equals to 1, that's only when I'm gonna call my next DFS. If it is 0, I don't care about it, right? So if the grid value at r, c, although like that 0 is not, if that value being 0 doesn't really matter to me, and it's also not like making me think basically this is enclave false, right? So this is, if this is equals to 1 and this is not part of visited set already, all right? So if this is not in visited, awesome. If that's the case, I want to run a DFS on it, this, which will return me E, and which will return me C. I'm just gonna call it count, or is E or is C. So I'm just gonna call it is E and is and num E. Makes more sense. So this will be returning me a child num count and child if that child is enclave. So but here I just need to like basically append do the this. So is in and is E, because I only want to consider only want to count the ones if that was basically its child was also not on border, right? It is a valid enclave. If that is, then I will return false, and this is how you actually or and it with the, or you can say like in a better way, this is better way. And all right, and then you can add your num enclave that you just child num enclave that you got. So this num E, number of enclaves that's coming from this neighboring cell. Finally, let's return. What are we returning? We are returning is enclave, and I think that's how we had it, like that's how we had it right here. So is enclave is the first value, which is a Boolean value, and then next thing is num enclave. So num enclaves, and this num enclave we were just adding. And I'm sorry, like I forgot to change this. I planned to change this, but I forgot. So this will be num enclave. Awesome. I'm sure there might be some typo. You guys might already must have seen it, but I am gonna go through it again and then just run the code, because I think that will be it. Let me zoom out. It's better to see the entire code all together. Awesome. So row and column, got the set, visited set, and I hope we have not made any typo with visited. Then running over all the grid, if it is equal to 1, then call the DFS, and also it's not been visited, then add everything to your answer. If is enclave, then num enclave is added to your answer. Finally, go through the DFS. Initially true, 1 is the number of enclaves in the beginning, because you are counting that as an enclave, that 1. But you will only add it if is enclave was not false, but you make it false if it was part of the border. Otherwise, you keep exploring all its neighbors only when they are 1, not visited, and we are kind of making a mistake here. You want to check it on the current new row and new column. Sorry about that. You want to check it on new row and column. That's what I was talking about. It's easy to make these typos, and I guess they are kind of lethal. Okay, let's run it now. I hope everything is correct. Awesome. Let's submit it. Let's see if is it even a efficient solution. Well, it is. It is 10%. Let me submit it again. All right, but anyway, let's write the time complexity is the same. That's the best optimal time complexity possible for this solution, and that is time complexity is big of n cross m. Worst case, that's the number of you're traversing the entire grid, even through DFS. Worst case, everything is all 1. You kind of store it into your visited set, so that is why. And your space complexity is also big of n cross n because of the visited. And I think that's the only memory we are storing. Otherwise, grid is given to us. Rest everything, this DFS might at the end of the day is implicitly end up adding everything, calling all the ones everywhere in the grid. Let's say everything was 1. At max, it is going to n cross m grid implicitly. By the way, that's it's calling this stack. That's how recursion work, right? It keeps calling on this stack, unless in the DFS it keeps going in. But I guess worst case it would be mostly either the length or the height, basically row and column. So it could be max of n and m, but this is because of visited. Visited is m cross n, but if it was part of the DFS, so this recursion height can go max up to a maximum of row or column, right? Or row plus column both. Awesome. Okay, let's go back to AlgoYogi, mark this problem solved. So as I said, this problem was quite similar to a closed island, but in closed island you were just considering if it is a closed island or not. But in this one you were considering both. Is it an enclave? If it is, how many number of ones or piece of land it has. All right, so next problem would be a number of provinces. So let's do it in the next video. See you guys later. Bye bye.